You should have asked me that.
Yeah. For now, we'll just let you guys kind of sit with it. All right, so let's do another couple minutes if you guys want, because this is a nice, easy way to start the year.
Yeah.
Any other questions about me? Anything you want to know to make you more comfortable as we dive into this year? You already have the hand up yesterday. Huh?
How many dogs do you have?
4. 3 Siberian Huskies and a German Shepherd.
How do you feel about late assignments?
You did not raise your hand.
How many cats do you have?
None.
You should
My
get
dogs would make sure of that.
Oh.
The dogs are taking over the house too much. I don't think implementing a cat now would work well. Either.
How do you feel about late assignments?
It depends on the situation. If it's just late because you just didn't do it, that's malarkey, and that's a life skill. If it's late because you have way too much going on, you have theater practice, whatever, and you decided that sleep was valuable, that's different. So it's all about situation.
Sleep is valuable.
Would you give us an excuse?
It all depends on the situation. But yeah, I'm fairly flexible with these things. One of the things we're going to talk about, and one of the little clips we're going to watch today, is that speed has nothing to do with mathematical ability, which is one of the biggest misconceptions with accelerated classes, is that somehow the speed at which I can do math is reflective of how good I am at math. That is not true. It's a common misconception, and Math Counts kind of pushes that misconception, but they have to have some kind of deciding factor, right? So for those of you who have been at Math Counts, yeah, speed does come into play there. That's because it's competition. That does not necessarily mean the person who did it faster is a deeper thinker. They did it faster, so odds are they didn't think deeper. Any other questions about me before we dive into that? SOS? Are you telegraphing me a question? You know what a telegraph is?
Yes. They have one at the War Museum.
All right. Would anyone know where the power button on the amp is?
Yes!
Ava, will you flip that on?
Yes! I think! He's like, I'm so proud about that.
Yes. Yep. Alright, so, like I just said, this film, again, from our YouTubians, is just iterating to you guys, and I want you to really pay attention to this, that speed does not mean ability. Thanks, you.
Do we have here? I'm never good at math. That is not true. How fast you are is not at all related to how good you are. Plus, lots of mathematicians are very slow because they think very deeply.
Yeah, math calculation isn't really important. What matters is deep thinking and understanding. Calculation is a very small part of math, but math is really a much broader subject about patterns and visualizations and ideas.
Wow, I had no idea that math was more than just numbers and calculations. I thought mathematicians think like me.
Exactly. So try not to worry about time, because speed is not important in math. Rather, what's important is being able to understand what you're doing, not how quickly you're doing it.
Math facts are held in the working memory section of the brain. And we know from the work of Cian Bylock that when people are stressed, they can't access that part of the brain. It's actually blocked. Now, schools put time.
So, wait, let's reiterate that. Literally, brain research shows that stress will work to block working memory, even things that you have memorized. Your stress can literally put up a roadblock and just say, you can't access this right now. So, this whole mindset and attitude and, like, framing yourself before you dive into things, that's important beyond just, like, yay, let's all be happy and enjoy it. Like, beyond that, it's literally ability to access the information.
Professional students in lots of ways. Even when teachers ask questions and take an answer from the first person that shoots up their hand,
Well, a lot of times
that
we will
gives
wait.
students the idea that what's important in maths is speed. But that's wrong. Speed is actually unimportant. What is important is thinking slowly and deeply about maths. And in brain studies, they found that people who learn maths facts by thinking about strategies to use, drawing and visualizing, instead of memorizing math facts, did better and were better able to use math facts in different situations. Even if you're put in stressful or trying situations in school, try and remember that maths isn't about speed, and if you don't do well in those situations, it does doesn't mean that you can't do well at math. Math success comes from thinking slowly and deeply, drawing, visualizing, making connections, and thinking about ideas.
So, realize that this year, as we go, it's not how quickly can we do this, it's how deeply can we think about this and how well can we understand it. So yesterday we started looking at this, and many of us got rather frustrated.
Yeah.
So we ended up essentially at this point, realizing that we increased by 2, increased by 3, increased by 4. We had a lot of conversations. We know the sum of the stages. We know we're looking for some kind of rule. We're looking for the 10th step. We're looking for the 55th step. We backed away from this for a second, and we looked at these for a hot minute, right? Did we analyze this and get to our rule section?
No, we just did the bottom one, which is back.
Like this? Or which one?
On the side.
Because I reprinted these.
It was the one that had the. It was like the.
It was this one at the bottom.
It's add 2 constantly.
This one here.
This?
That one.
Yeah.
So this is actually the same as this.
Oh, okay.
Check it out. 1 and 1, 3 and 3, 5 and 5, 7 and 7. They're each increasing by 2. So even though they look different, the rule and the behavior is identical. Now this, because it was just an arithmetic relationship, always increasing by 2 consistently, that's manageable. Easy to solve. Sorry, ignore this stuff. A student got a little messy. So we end up with a situation something like this, and we're able to obtain it. But what about this? Who put some work into this beyond class yesterday? Just curious. Okay. Who thinks this? Does anybody think they have a solution process?
I know I did because my dad helped me a little bit.
You want to come and try to explain it? Do you want to fresh one of these to draw and write on and stuff? Or do you want to use this one?
First one.
Your book.
I
I'm gonna run out of these because I keep using, like I just keep writing all of these. My smart board, I need to restart my entire computer, so we can't use the Smart Ink right now. So we're just stuck using. Yeah, you can use the Sharpie, the pens, or whatever.
So basically, my dad had me told me a hint to mirror the shapes. So he had us me look at mirror 3, like dots, and just mirror it so that it was like that. So then he asked me how you usually get how many cubes are in a shape, which is area. So the easiest way to find area is to make it a square rectangle. So he told me that we folded the shapes onto each other to make a 4x3 rectangle, which is, well, the 3 is the figure height. So we know n equals.
So wait, that's double figure 3.
Yeah.
Right? Okay, just making sure we're all on the same page.
Wait, what?
So he took figure 3, made each of the squares a dot.
Oh, okay.
Just to make
Okay.
life easy to work with. Drew 2 of them, and then essentially took one this way, one that way, and fit them together and make a rectangle.
So what I did then was take the area. So 3 times 4, because 3 and 4, 12, which isn't quite 6. So we have to divide by 2. That tells us that since 3 is n, it's n times 4. Well, not quite times another number divided by 2. Then, looking at the 4, we find out how to get the 4, which is just plus 1 from n. So it's n times n plus 1 divided by 2.
I know what you're saying.
Okay, sorry. I let my mind wander a little bit, so I didn't hear that last bit. I mean, I was focused
So,
on
everyone grab a sheet of graph paper.
Yeah.
Grab a sheet of graph paper.
I was just
And then,
I was thinking in my own little world right there.
Started walking through it, and then I started blowing it. Wow.
I always math. I love math.
so, I'm going to show you the Einstein story that we talked about yesterday.
Okay, Mr. Hall doesn't get how that fits.
And I didn't feel like explaining it right in the moment because he came and he asked me, and he's like, "That doesn't really help with this problem, does it?" I'm like, "Well, it all depends on how you look at it, because it can." So we know that Einstein story from yesterday, his teacher said, I want you to sum the numbers Now, what I told you guys Einstein really did was something like this and start making pairs. Now, to explain that using the way that Chris just tried to explain to us, this is his objective. He is trying to sum this. Let's call this set S, because he's trying to find the sum. So the sum will equal that all added up, right? So, sorry, I asked another frame. So Chris said, I'm just going to double my shapes. So essentially, I'm going to make another set of S if we're still just doing this algebraically. We'll come back and apply it to the geometry for the stair step. But instead of putting these in the same order, I'll flip the order around. So now I can have 100 plus 99 plus 98 plus 97 plus all the values down 3, 2, 1, and 0. Now what we see if I look at what will happen when I have two S's, I'm going to have 100, the sum of 100, how many times?
49.
Well, how many values do I have? 0 to 100. Well, and 0 doesn't really mean.
Or 50 times.
2S. We're looking at
So
both.
100 times?
100 times, right? Because 1 to 100 is 100, not the difference between, but how many values do we have? And each of them have a pair, right? So is it 100 or is it 101?
Oh. That's
100, right? So here's the problem with this. Now we're using 100 twice. But this 100, we don't normally use quotations in math. But that 100 is only because this is happening. We don't really want 2S. We just want the sum. But if we divide by 2, then we have 100 times 50, and that ends up being 5,000.
Is it 100 and a half? Because you were talking about how 50 doesn't have a pair. So is it 5,550?
I'm waiting to let the wheels turn. What was my first term supposed to be? 1. I was supposed to start at 1, right? This is not allowed to exist. Unless I make that term 1. And if that's term 1, this is term 101. So you got to be very careful when you think about number of terms. If I use 0, it's a term. So I now have 101 terms. If I only use this, then I have one less pair. But if I start with the 1 and do this, if I do 1 and 100 or 1 and 99, it changes what we do. But so that's the algebraic. Are we understanding like this? Be careful with this because depending on number of terms, that'll get tricky. But if we think about this geometrically now, so you get the idea of pairing up and all the pairs will be the same? Mm-hmm. Yes, maybe. Yeah. So think the same thing, except I should have grabbed more graphic than just a sheet. Not really. That was handwriting. So let's draw our first 5. Or, I mean, yeah, really, we should do first 5. Now, here's where this gets a little tricky. Because the Einstein story is a little bit of a stretch for this application. So actually hold up on your drawing because we're going to head down a road that we don't want to head down yet. If we look at the Einstein method of doing this, we're going to be matching the shapes up and like doing the first shape with the last, or the first figure with the last figure, second in with the second in. What we really want to know is how many squares in the figure, which really the sum of each figure, the total number of squares, each figure is the Einstein problem. Now let me explain that. If figure 9, so let's say squares at 9. So figure 9 is going to involve a stack of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
So is it basically using the term number as the 100? So we have like 10 terms?
Hold on just a second. I will answer that. There are 9 blocks, 8 blocks, 7 blocks, 6 blocks, 5 blocks, 4 blocks, 3 blocks, 2 blocks, and 1 block. So if Einstein's teacher had just asked him to add up the numbers from 1 to 9, he could have paired 1 and 9 to make a 10.
Oh, okay.
8 and 2 to make a 10. 7 and 3 to make a 10. 6 and 4 to make a 10. 5's all by his lonesome. How many sets of 10 did I make? 4. And then a half set, right? So I know that I have the sum, that 10, so we could say least and greatest. Times, how can I make a rule? And this goes back to Chris's example. How many sets of 10 do I have?
4.
4.5. What step of the sequence am I on? What Chris was trying to explain is if I have another S sub 9, and I have the 9, 8, 7, 6, 5, 4, 3, 2, 1, and I flip it around, sorry, you can't really see what I'm doing. If I had another, but it went 1, 2, 3, 4, 5, 6, 7, 8, 9 up that way,
That was what he was trying to
yeah, the 9 and the 1 would make a 10. The 2 and the 8 would make a 10. The 3 and the 7 would make a 10. But then we end up with double what we actually would want. So this would be 2 times the squares at 9.
Okay.
And to get what we need, we would have to divide it by 2, is what Chris was trying to show.
That's so cool.
I like that.
So,
That's cool.
still, this brings us back to your question. How many cubes, squares, will you need at the 55th stage?
Wait,
Does
what's that
anyone
say?
know how to approach that now?
Wait, what does that say? 2,
So this,
3.
so this is visualizing, Ava. If I had this stack, this 9 set, if we want to say.
No, I don't. I'm talking about down
I know,
there.
I know. And another 9 set that I didn't draw, and we put them together, I'd have 2 9 sets. But I'm not looking for 2 9 sets. I'm only looking for 1, so I have to cut it in half. So what this is really doing is this formula is a manipulation of what we actually need, because we don't want 2 of these together. We only want 1.
So
but
is it 2SN?
That's S of 9. Well, it should be N. Yeah, N for any case. But really, this would just end up, so if we plugged in S of N there, this would just come out to be S of N. because it's a redundant. This is a cyclical. It's redundant because we still didn't know, well, how do I get S sub n? Well, I paired things up, so I used the sum. How many of those sums do I get? Half as many sums as I have stacks. So here's what makes it weird. If I go to the 10th, this is going to get real messy, but if I go to the 10th, right, and I add this other stack, now what would my first and last add up to? 11. 9 and 2, 11. 8 and 3, 11. 7, 4, 11. 6 and 5, 11. Because S of 10, well, 10 divided by 2, there are 5 perfectly matching sets. But then my sum would be different. Right? But my n would be different, my sum would be different, because my sum has to be the lowest and the greatest. Yeah, depending on how you look at it, like how you manipulate it.
Yeah.
So, if we were wanting to look at S sub 55, or S of 55. So we're going to do a really, really short-handed on this. The first one, I hate that plastic stuff on these things, would have how many?
56.
If it's step 55. Yeah, 55. All the way to the last one would have 1. So the sum would be 56 times, yeah, the 55 divided by 2. And actually, we can divide by 2 wherever we want, so we can do the 56 divided by 2, and then times 55 if you want to make your work easier. So we can get 28 times 55. So how many squares will we need in stage 55? Whatever.
Yeah, on the calculator after one formula in, but 1,540.
Does that work? 1540? 28 times 55. I get 1540.
Okay. I just plugged in.
No, I got the same thing as you, I think.
Yeah. It's just I plugged in the actual formula I wrote down. It's the same one you wrote down.
So, here's the extension piece. And I'm going to give you some time to work this on your own. The next question that it asked, that we were looking at yesterday, was, is there a stage or a height of steps that will use 190 squares? So I told you the milk crate example yesterday, right? Where I was going to bring in milk crates today. I did not go back to the gym, so I did not bring them in. But if I had in the closet at the gym 190 milk crates, and I just start 1 step, 2 tall step, 3 tall step, and I want to use them all, will I make a perfect staircase, or will my last one like have some left over and not make a hole? So that's for you to solve. If we use 190 squares or 190 milk crates, whatever you want to think, will it create a perfect staircase? How can we do that? Use what you already know. We might get a chance to look at that. By the way, I had a 7th grader who, not that he could solve this, but he was much further down the path than I thought he would be. Because you guys were saying, you're doing this with 7th graders?
Was he farther than us?
No.
Okay.
But he was realizing, some things that were, kind of important. So I did this today with them. Is this today's or yet? Yeah, I did this today with them. We did this for a few minutes, let them struggle, let them color it, let them figure stuff out, and then we went straight to here because this is a whole lot easier. This is linear. So then to get the idea of linear versus not linear. So all they have to see right now is that's not linear.
I like it. It's so easy.
I like it.
Or let's just do it on our head.
No,
You
Daddy.
can't.
Kidding.
Draw it all out on the paper.
Sure you are, Daddy.
I am so busy. Even cheated.
Why do we say my full name? It's not like full.
Kind of guessing.
I never survive.
Wait,
That was it. Okay.
What is this?
Oh, you can't. No. You need to know that it
What you want?
Hold on, I'm confused. What is this? N times n plus 1, y n times n plus 1.
Are you looking?
Yeah. Did you know that? Did you not know that?
One.
190. So yeah, we're not that far down, right? We're coming back 6 steps.
So I'm multiplying it 2.
Okay, so yeah, you're still using that whole like visual matching up
You
method.
have to write a multiplying it to see.
Yeah.
So am I saying the right thing?
I'm just left handed, so.
So hold on, let me frame you for a second, because I see a couple things on some people's papers that I think I can help you think a bit easier. So we had this that is kind of a result from coming over from here. But when we look at this sum, how did we make this sum?
We added the least and the greatest.
And what is the greatest?
The term number. It's
Well,
term
so think back to this, S of 9. What's the greatest in S of 9?
9.
9. So the greatest is always going to be,
The term number.
which is,
The term number.
what do we use for the term number?
Oh,
N. So this is really N,
plus 1.
and the least is always 1.
So
So this formula we can really manipulate into the sum just being N plus 1 times N over 2. Which is where, and this is what I was trying to get you to like actually explain to me, this is where Chris got his formula of N plus 1 times N, or N minus 1 times N, depending on which you're using as your N, which is why you gotta be careful on like, is N my term number, or is it the previous, or you just have to know what you're setting up. Times 2. That makes sense? The handheld sharpener normally works better. You can try that one, but the handheld right up here on the main table.
What? I'm sorry.
Right here, the handheld one's right
Oh,
here.
okay.
Just buy all my pencils, or just grab one of my pencils.
Wait, so what's the question state?
So if we go back to the visual representation, right?
Either 190 or
2 of these, 3 by 3. If I stack another 3 by 3, so I stack another 3 by 3 on it. Now, 2 times figure 3 is actually N times N plus 1. Because I make a rectangle that is now 3 by 4. We're using N plus or N minus?
Plus.
Okay, making sure. We were using minus in the other class. Sorry. This situation, because we don't have the center section, this is where we're using N minus 1 situation. That's why my brain, sorry for misspeaking. I thought for a second you'd been using the minus. That's how we get that. If you think of it visually, I make a rectangle. N times N plus 1 is going to give me the area, which is the number of squares. Or I can just do this. So really what we're saying,
I got an answer, but I'm not sure if it's right.
what would I do from here?
Multiply by 2.
Multiply by 2 on both sides, which gets me left side.
380.
Ooh, we're going to go ahead and distribute. N squared plus N. Like it.
That's where I got to. And then
Mmm.
but I'm pretty sure.
I just used the original formula, and I got an answer. But I don't know if it's right.
That would just move the N.
Then you just, oh wait, never mind.
Anyone know what the word quadratic actually means?
Yeah,
It's like
it has to do
square
with 4.
and then the 2 and then the.
But do you know what it means? So hold up. I'm trying to figure out where we are at the start of the year. So I know we've kind of been really random the past 3 days. If somebody asked you to tell them the solution of a line, like on a graph, what would that's really, I don't like that question either, actually. So when we talk about the solution of a quadratic, what's a quadratic look like? What do we call the graph of a quadratic? A what?
Parabola.
A parabola, right? So we know that quadratics can easily look in the form of, where did Desmos go? Apparently he got kicked off my favorites. So we know any quadratic, right, makes a parabola.
Isn't the solution, didn't you need another line to find the solution?
Here, oh, sorry, that popped away. I'm going to slide this up to the TV. If I make this quadratic, all I got to do to set this equal to 0, because a quadratic has to equal 0, subtract 380. So we end up with n squared plus n minus 380. Well, we could try to factor it. Actually, this is not bad because we don't have a coefficient on the n squared and we don't have a coefficient on the n. But you have to find like a perfect, this has to be a perfect square trinomial because these don't have coefficients. So it's going to be messy. It'll solve, but it's only going to have one solution and it's going to be a bad number because it's not a perfect square. Because it's close to 400. It's close to 20. So if we were factoring, let's take a little bit of liberties with our math right now. If this was n squared plus n minus 400, right? So let's just make our life easy for a minute. Then we could factor it, and we'd say, and if you don't know how to factor it, it's okay. We are going to get to trinomials. N and n will make my n squared. The plus and the minus will cancel out. We need to end up with 1n left over. So these can't actually cancel each other perfectly, but we know it'd be approximately 20, right? These would have to be off by 1. These right here would have to be off by 1. So the positive would have 1 more. Are we with me? This. So if I used 20 and 19, this has to be off by 1. Well, that won't make 400. Now we'll forget about the 400. But what is 20 times 19? It's 380. Which is actually, so hold on. So for a minute, I let myself think easier. I let myself think perfect square. I know I'm not actually shooting for the perfect square, and I know I'm not actually wanting to have these two numbers be the same. But for a moment, I thought like that, just to make it easier so I could get close. When we look at solutions, what do we have to do here? If this equals 0, my solutions would be n equal to, should really pull this back over if I'm talking through all this and it's not on the video. So we've done all this, right? We let this for a moment be 400 even though we know it wasn't. 20 and 19 work for my positive n. Positive 20 and negative 19 work for my negative 380. But then for this to equal 0, this product, one of these has to be 0, right? Or both. So for this to be 0, what would n have to be? 19. For this to be 0, negative 20. Could I have a staircase that is negative 20 tall?
Nope.
So this solution doesn't make sense. Our answer is 19. We'd be on stage 19. Now, if we didn't want to factor it, and I use my graphing utility, x squared plus x minus 380. What I would do is zoom out and see where do I cross the x-axis. 19. Or a solution that doesn't make sense. So likewise, how can we modify this for any situation? What if I asked you, my closet actually has 500 milk crates. how would I modify my quadratic to test if that would work? How did I get that 380?
Oh.
Remember the original question that we were at? How did I get my 380 for the presentation? Yeah.
Multiplied the 190 by 2.
The amount that I had, I doubled. So if I actually had 500 milk crates, I just changed that to 1,000. Would it work out? Nope. 31.127. So 500 milk crates would not work perfectly. Now I might be able to use like 480. I don't know. That'd be like 960. Oh, we're closer. And then I could play with this until I got to a point that this intercept worked, or build it yourself using the binomial multiplication. So we know that we have x minus something. So if you've not used Desmos much, I'm going to start to blow your mind with Desmos. And then x plus something. But that x minus and x plus, one is k, and one's k plus 1, right? Do you agree with me on how we got, like, if you look up on the TV, how we got the 19 and the 20, they have to be neighbors? So now if I do this, I can play with my slider for k and say, okay, if I have, what's k represent? We ended up, k was n, right? The term. So if I'm at term 10, and then if I solve this, if I figure out what this quadratic actually equals to, I can figure out how many boxes I need. I can play with this a lot of different ways. I'm just trying to get you guys to see like how we think, how we look at this. So when we started this problem yesterday, when we started looking at the stair step, the pattern, and I asked you, tell me how many boxes we're going to need for stage 55. Did it seem all that manageable?
No.
No. Now that we took some time, we used some resources, and we used our teammates, we're there, right? We finished it. We have our formula. We know our sum times n divided by 2. We know that that sum actually comes from n plus 1 and n. So, like, we figured all this out slowly but surely, chunk at a time, we got it. Yeah.
So when I use the equation, the s of n equals the sum times n over 2, I got 190 for 19.
Yeah, that's you're supposed to.
Yeah, but if we're looking for 380.
No, so we got the 380 because we looked at what if I have
okay.
2 sets.
Cool.
Then we backed ourselves down.
Alright, we're good.
Because this number is a working number that does not directly relate with a quantity of, I mean, it is twice the boxes that we use.
Yeah, I
Twice
just kind
the
of
milk
forgot
crates.
because we took so long.
So, like, if I told you the tallest stack is 15, then you know you've got 15, 15, you solve this out, and then you could figure out how many. Questions? All right, we have about 7 minutes. So, and we're going to keep the books in here. I just want to show them to you guys so you get a little bit of exposure with what we're going to be doing. So, grab a book. We're not going to keep them in here forever, but for this weekend, I still have to label the books.
Oh my gosh, they're
So
so
let's-
big for us.
No, for you. We don't
Like, do you keep them?
no, for the year.
Like in our locker?
Yeah.
Can you
Or
carry these
here.
around?
You don't have to.
They're so big.
If it has plastic, go ahead and rip the plastic off for me, please.
Wow.
Oh yeah, they're supposed to send me one more extra. Can I borrow somebody? So all I have is the teacher edition. Nice use. Throw this away for you. Well, you two can share it, but I figured this needed thrown away anyways. Sorry. No, I'm not trying to be mean to you. All right, we have about 5 minutes. Take 2 or 3. Leaf through this and see what you realize. What sticks out to you? What's different?
Seriously. Skateboarder.
What?
Skateboarder.
A skate? Oh, it's so cool.
Oh, that's just being
Probability, yes. I learned how to do probability. Nothing touched on probability.
We're gonna eventually just forget about the new word.
I'm not too great at probability.
So, because we're running low on time, I'll give you guys some more time to explore this on Monday. But we have a little under 5 minutes. So let's just crack this open. You will eventually write your name in here, but I will assign books, so please don't do anything with that yet.
Sir?
Go ahead and flip on to. Note to students, we'll read this on Monday. Check this out. So, I wish this would get back in focus. Flip to where it says the
We might not have
12, but it's still less. So it's 14 months.
Alright, so check this out. So in a chapter, so like look at chapter 1. So don't flip to it yet, but look right here in the index page. Notice that chapter 1 is broken up into 3 sections. Notice that we have attributes of polygons, making predictions, perimeter area, angle pairs, angle relationships. Notice that we're bouncing around through different topics. This is a method of learning called spiraling. So flip to chapter 1 then, page 3. Notice that it gives you the brief outline. What's in section 1.1? What's in section 1.2? What's in section 1.3? Then one of the biggest differences that keep like kind of freaking people out. Do you see a page full of numbers and symbols?
No.
No. I don't see any pages full of numbers and symbols. I see some pages with some shapes.
I found a few numbers and symbols, but not many.
So, check this out. This, right here, if you flip back to page 3, this is question 1 from chapter 1.
Oh, it's word
If you flip, chill, that would be done during class. That would be our lesson. We'd be talking about that. Then question 2, we'd be discussing through class. Then question 3, we'd probably still be discussing through class. This is like our lesson as we go. And then also, I like how this paper feels. I know that might just be me, but it's like legitimate paper. This, hold up, hey, check this out. This would then probably be your homework. Questions 4 through 8. And then the next day, we would pick up with question 9. Not another question 1. Not which question 13 are you on. Flip deeper into chapter 1. You'll see question 38, question 39. All the questions are sequential. So question 1, or chapter 1, does not have 2 different problem 3s. If you call me and you say, hey, I'm on chapter 1, problem 3, there's only one of them. I know exactly what you're talking about.
That's good.
But that doesn't mean the questions
they
get
made
really
very sensible decisions when writing this textbook. So,
even then, when you get to like the later chapters, it's like question 312.
Like question 1-56. But like we've been working through that in class.
Are we gonna have to do every single question from chapter 12 at once?
What do you
Oh,
mean?
it starts over in each new chapter.
Oh
and
no,
then it just
not
went
at once,
on
of
and
course.
on
That'd
and
be
on.
as we learn the chapter.
Question 1,200.
So, if you can do me a favor, I will let you keep these next week, but I gotta label them and I gotta get your names in them and we gotta cover them. So, if you can bring them back here, and at some point in the next couple days, like the next couple school days, bring in a paper grocery bag. I'm going to teach you how to make a book cover. Bring in a paper grocery bag.
When we do not need to bring this home.
Sure, if you want to keep it in my room, you can. If you want to keep it in the locker room. Look at that. Sure, it's all about kitchen paper.
I saw the one we had on fire, so that's it. Go.
Alright, that's all the time I have. I really try to respect the Matrix and get you guys back that way. So, love you guys. Have a great weekend. But get out of here. So I got 7th graders coming and you got class to get to.
That's how it is.
Dude, I'm so excited to have a textbook.
I know.
I'm actually.
That's a really great text.